Hello and welcome. Well, I've done a couple of videos on this Vevor XY table. They call it a mill table, but I don't really think it's an accurate description of it. It's more like a positioning table for your drill press, or that's the way I see it. But that's key to making things in the shop, is accurately drilling holes. And this mill table is really good for doing that, XY table. We're going to expand the capability of it a little bit today. I want to increase the X travel and maybe to some degree the Y travel. Anyway, let me show you what we're going to do. The travel here, going this way, is fairly good. You can see it travels past the dovetails right there. And I kind of messed up on my DRO sender right there. That's what's limiting the travel, but that's still pretty good that direction. But going this way, it stops about an inch from where it should be, and actually it could go another inch further. And what's stopping it is this thrust bearing right in here. You can see it right there. It's hitting the casting on this section. So, I don't like these lead screws in here anyway. They're 4 millimeters per turn. So we're going to replace this section right here and put in a different lead screw and let that go past right there. I think it's going to work good. Here's everything we need to do this project. This is 1¼ inch stock. I think it's 5/16, but it could be 1/4 or 3/8. It's a piece of 1-inch pipe. I ground the galvanized off it because we're going to weld on that. I've got a piece of all thread here. It's stainless steel all thread, and the reason it's stainless steel is because generally speaking, the stainless steel all thread is much better quality. That's going to be our lead screw, and it's going to be, these are thrust bearings, and there's going to be one on each side. Now that's going to slow down the travel of the table a lot. There are other options. This is a 3/8 10 Acme thread. I got it from McMaster Car. But the nuts that go along with this are fairly high priced, and this right here is a little pricey too. I don't remember what I paid for it. But we're going to use this. It's one turn will be 1/16 of an inch, but I've got DROs on the table, so it won't really matter. The 4 millimeter pitch that's on the table currently is a little aggravating because it's hard to hit the number on my DRO. It's very fast moving. So first thing we're going to do is make these plates, and this is for the Y-axis and this is for the X-axis. So we're going to use the XY table to drill these, and then we're going to take apart the XY table and install this. Okay, I need to go in 5/10. 3.74. Okay, the next thing we're going to do is cut little pieces of pipe off, just a little bit more shallow than that thrust bearing right there, and we're going to weld it to there. And that'll keep everything centered on this plate. Okay, the inside diameter of this pipe is amazingly close to this thrust bearing. So we're just going to go inside. This is just regular water pipe. I'm going to go inside and we're going to open that up just a little bit. If you don't have a lathe, you could probably do this, just cut little rings off, but you'll have to take a burr grinder or something to the inside of that. Okay, I'm going to cut these off just a little bit shorter than these thrust bearings. Okay, we need 4 of these. Okay, my idea here is to bolt that on there. And weld that right there. I think it'll work good. Well, I thought I got most of the galvanized off of that, but there's still a lot of galvanized on there, and that's not good. But okay, these thrust bearings are made in such a way that this side centers the shaft. In other words, this hole is smaller than this hole. So if you put it in this way, it's kind of a snug fit. I think those kind of distorted a little bit, but they'll go in there. I just don't want to get them stuck in there yet. I want to paint these before I get them stuck. The rod will go through there, and we'll put a nut right there, and it'll be under tension, and it clears the hole on the back side. So you're not, this is not, the threads are not a bearing surface. Okay, this is going to be bolted right there. But that's really close to hitting right here and here. I don't know if that's centered or not. Pretty close. But I'm going to grind that off right there on both of them. It could cut it off, but I'm going to grind it off. Oh yeah, it gives me plenty of room. Okay, there's the bearing brackets for each end. I think it came out pretty good. I think it's going to work good. Now it's time to take this thing apart. Take the DROs off, take it off the drill press. Yeah, let's see if my brackets fit. I think that'll work. It's a little closer to the top of the table than I thought it would be. Yeah, let's take it apart and take a look at it. I may have to slot these holes to move that lead screw down a little bit. Really close to the table right there. Okay, I drilled these brackets in pairs so I can make it. I got this one bolted in on the original end of the slot where I drilled the holes, so I can measure over like this. Make this one in the same spot and drill my holes. And then I'll continue with the tap size drill. Okay, this right here is a little tighter than I expected it to be, but I got it 1/4 inch down, and I'm about a 32nd of an inch from this lower piece right here. If I had to, I could grind part of that off, but I don't think I'm going to have to. So I'm going to mount this one on the other side. I took it back off to get the table on, but okay, the table is centered from the outside here, and the screw needs to be centered. So I've measured in 2 3/8 from each side. Unfortunately, this is just a hair taller so that I can just sit here and hold it against the ruler and start my holes, hopefully, without moving. Okay, I had to enlarge the holes very slightly in that to get it to be square, drilling by hand. That's why this XY table is so important, so you can, oh good. Oh, I think it's rubbing the top. Yep. May have to mill that casting on the bottom of the table just a little bit. Either that or mill the top of that off. Guess I'll mill the top of that off. Or the bottom. Bottom would be better. Oh, heck yeah. Now I can take a transfer punch and mark that. Okay, I need to drill that out to 5/16, which is a 3/8 16 drill size. I got a nylock nut on this end. Now I haven't got any lubrication on it. Obviously haven't got the table secured. Oh, that's a lot of travel. Take this all the way in, right there, and make the handle out here where it doesn't interfere with the DROs or the table. Well, that hand wheel is overkill. Don't need that kind of leverage. Let's see what we can come up with. Oh, that's it. I don't know what I was making out of those. There's a piece of pipe I cut off. That'll work. Okay, I got a piece of copper tubing, just a spacer on there. Okay, let's move on to the lower lead screw. This is the lower lead screw nut. And it's going to be the most challenging thing about making, I'm going to have to put that on the bottom. Definitely going to be challenging. I think those screws are sticking through. Yep. I'll have to fix that. I might change the design on this a little bit. Just forget about the bracket on the back. We'll see. Yeah, that fit good. If I put these back to back, there's a hole back here. Let me show you. There's a hole back here that lines up perfect. I can just put those back to back to keep the backlash out. Yeah, I think I like that idea. Looks like 3/4 inch. 3/4 inch from where that mounts to this right here. The bottom, so it's 3/4 inch from here to the bottom of this. So that's what I got to do for my leads or my nut. Kind of confusing. Okay, it's 822 thousandths from here to the center of that lead screw. Well, something's off center. And I went by, actually I measured the center. Something's off. Tell you what I'm going to do. I'm going to open up the holes in this bracket. So I got some adjustment there. Okay, I figured out something. Something about stainless steel and mild steel, which is what I made my lead screw nuts with, are not compatible. I'd run this in and out one time and it would start binding. And then I'd run a tap through the nut and it would be okay for one travel, and one complete travel and it'd start binding again. So I'm going to change this lead screw while I got it apart and eliminate this problem, I hope. I don't know why steel would be incompatible with stainless steel. If anybody knows the reason, leave it in the comments. I've never seen it before. Oop, wrong way. I do believe that zinc plated, maybe the zinc plating has something to do with it, but steel on steel is better than stainless steel on steel. These are much smoother lead screws. Okay, the steel lead screws are definitely better. Okay, let's replace these hand wheels. The steel threaded rod definitely works better than the stainless steel, but this one's still a problem. If you turn it, it works fine, but if you turn it with a hand crank where you're putting sideways pressure, apparently that lead screw in there is flexing in the nut. For some reason though, it's worse at this extreme when the nut's closest to the pivot point there. And I can't figure that out. But I think a larger hand wheel will resolve the problem. Okay, first thing I'm going to do is get rid of this recess right there on the dials. Cast iron. Soft but messy. Wow! Nailed it. Honestly thought that would be a hair oversized, but that's good. Well, I was going to thread the end of that and put a nut right there, but I think I'm going to put a screw in there. So I need to make slightly shorter than the depth of that. I like that. It works good. Wobbles a little bit, not bad. Okay, next one. Okay, I need several spacers, 180 thousandths. Well, there's one DRO attached. Forgot how I had it mounted there. I got the table mounted backwards. The holes for the DRO on this side. Here, let me swap that around and then we'll continue. Okay, I know you can't see the handles, but that's almost no backlash. That's the amount of backlash. That's way better. Try the other axis. It's even a little better. Very cool. Well, that about wraps it up. I'm very pleased with it. For a while there I thought, boy, this is not going to work out too good, but it's working great. Now, this handle, redoing this handle was what it needed, and the steel lead screws, the steel versus stainless steel. Stainless steel just did not work. In fact, when I ran the table through and back with the hand drill, when I went to put the table back in, it locked up. It galled the threads in there. This works perfect now. Wonder what the deal is with stainless steel. If anybody has any idea why it's doing that, let me know in the comments. It's much easier to deal with now. It's a little slow, like if you got to make a big move, but if you got to make like a ½ inch move or something, it's ideal. Anyway, thanks for joining me. Be sure and subscribe and ring that bell. And thank you, Gary, from Bowling Green, Kentucky, for the I like it sign. That's pretty cool. I like it. I like it. One of my viewers made that for me, cast it out of aluminum. I painted it and then milled off the surface. Kind of looks rough in there, but overall I like it. What do you think? I like it. Thanks for joining me. Be sure and subscribe and ring that bell.